This tutorial starts by looking at how you can recognize the difference between an element, an ion and a compound from their formula, and then looks at the properties of ionic compounds. So you need to know what an ion is. It's a charged atom, or indeed a charged group of atoms. Recognize the difference between an ion, an atom and a molecule, and explain why a substance is an element or a compound from its formula. So here's a group of formulae, and let's work out which ones are ions, which ones are atoms, and which ones are molecules. So, okay, first of all, ions have got a charge. So, let's look for the ones with the charges, and I put a nice ring around those ones which have got a charge. First of all, we've got the calcium ion here. Then we've got the nitrate ion here. Now that's a group of atoms with a charge. Then we've got the chloride ion here. That's a single atom with a charge. And finally we've got the hydrogen ion here. So those four are ions because they are atoms or groups of atoms which have a charge. Now we'll look at which ones are single atoms. Well, if there's a single atom, then there'll only be one symbol and there'll only be one element there. So this one here, argon, that shows a single atom of argon. This shows a single atom of titanium. This one here shows a symbol for a single atom of potassium. And this one here shows a single atom of cobalt. Now you can recognize the symbol for an element because it only has one capital letter. Symbols for elements either have just a capital letter or a capital letter and a small letter after it. Next, there are some here which are an element but in the form of a molecule. Hydrogen here and oxygen here contain only one element because they've only got one symbol, but they're actually composed of a molecule containing two atoms of that element joined together. Finally, there are the molecules which are made up of more than one element, and these ones are methane here, phosphine, carbon monoxide and water. These are all molecules because they consist of more than one atom, two or more atoms joined together, but here, unlike the ones in blue, the atoms are of two or more different elements. So they're compounds. Looking again at whether things are elements or compounds, again an element has a symbol which will have a capital letter or a capital letter and a small letter. So there's more than one capital letter, then it's a compound because there must be more than one element combined together. So looking for the elements, calcium is an element, hydrogen is an element. Now here we have an element as well. Even though it's in the form of a molecule, the hydrogen has got two hydrogen atoms joined together, but it's still an element because it's only got the one element hydrogen there, only the one symbol. NO, now that's actually nobelium, but it's not a familiar one, but it must be an element because it's just got the one capital letter, and platinum, whereas the compounds here, which contain two or more elements joined together chemically, are the water, because that contains hydrogen and oxygen, and the nitrogen monoxide here, because that contains nitrogen and oxygen. Here's a past paper question. Look at this diagram. It shows a lithium atom. Now the outer electron is removed and it forms a charged particle, Li+. What's a charged particle such as Li+ called? Well, we know that that is called an ion. The second part of this tutorial concerns the properties of ionic compounds, and you need to know two compounds, particularly sodium chloride and magnesium oxide, and you need to be able to compare the melting points of these two because of the difference in the charges of the ions. An experiment you may have done at school is to put some sodium chloride into a beaker and see whether the crystals of sodium chloride conduct electricity. Well, they don't. But if you then add some water to the sodium chloride and stir it to dissolve the sodium chloride, the solution does conduct electricity. Now we know that sodium chloride is an ionic compound formed of ions, and in the solid these ions are held together by electrostatic forces. That means they can't move around and can't conduct electricity. But when the sodium chloride is dissolved in water, the ions are able to be released from each other, are free to move around and can conduct electricity. And there's another way that we can get the sodium chloride to conduct electricity, and that's by melting the sodium chloride. This also allows the ions to be free to move. Other ionic compounds like magnesium chloride or sodium iodide, for example, would also conduct electricity in the same way. So, sodium chloride is an ionic compound. Here's two diagrams from the internet, both of sodium chloride, showing it in a slightly different way, but certainly what you can tell is that the sodium ions and the chloride ions are clustered together in a very regular cubic fashion, where each sodium is surrounded by, in total, 6 chlorides, and each chloride is surrounded by 6 sodiums. There are very strong attractions between these ions called electrostatic attractions. And because these attractions are so strong, it takes a lot of energy to separate them. Therefore, they've got a high melting point. As we said before, because the ions are in fixed positions in the solid, they can't move, and therefore solid sodium chloride will not conduct electricity. However, we can get the ions to move either by dissolving it in water or by melting it, and therefore both a solution of sodium chloride and molten sodium chloride do conduct electricity. You're also expected to be able to compare the melting points of magnesium oxide with sodium chloride. Now you will be given the melting points or asked to comment on one being higher than the other. Here the melting point of magnesium oxide is given as 2852 degrees, whereas sodium chloride is a mere 801. Still high, but not nearly as high as magnesium oxide. Now when you look at the structure of magnesium oxide, it's again a cubic structure. And it will have similar properties in that it will not conduct electricity when it's a solid, but it will if it's molten or dissolved. But here, of course, the difference is that magnesium and oxygen are in different groups to sodium and chlorine in the periodic table. In order to form an ion, magnesium needs to lose 2 electrons and oxygen needs to gain 2 electrons. So the charges are Mg2+ and O2-. Because these ions have got stronger charges, there's a stronger attraction between the ions, and it takes much more energy to separate them. The ions are also smaller and so compact tighter together. For both these reasons, stronger attraction means that more energy is needed to separate the ions from each other, and therefore a higher temperature is needed to melt it. So, magnesium oxide has a higher melting point than sodium chloride because there are stronger attractions between the ions.